All right, so let's go through part one of all of these review questions. First thing I want to say is make sure that you have your reference chart on your desk, on your work area, so that you can reference all of these formulas and rules that we're going to use to solve these problems. You'll have it on your final too, so make sure you're looking at it. All right, number one says, write the equation that best represents the line on the coordinate graph. So this is linear equations. The easiest and most useful is that y equals mx plus b. That's our slope-intercept form. So I need to get the slope and the y-intercept. So y-intercept is easy. It's where it's crossing the y-axis. That's my b value. It's at -2. Now I need to calculate the slope. First thing I want you to notice is this is a negative sloping line. It's going down left to right. So when I calculate my slope, it needs to be a negative value. Okay, to get slope, we're going to use rise over run. Oops. So rise, 1, 2. So up is positive, so we went up +2. Now we're going to the left, If I go to the left, it's negative. You see on the number line that it's negative. So -1, -2, -3. So our slope, we got a negative value, -2/3. And you're ready to plug it in. So y equals -2/3. X and Y always stay there. Our slope is negative, so -2. And that's it. We're going to do the exact same thing, but now I have a system, which means I have two linear equations. My solution is highlighted by that point. Remember, if I ask you for the solution, it's where those two intersect. So this one is at 3, -1. That's not what this is asking, but I wanted to make sure we talk about it. So let's do the red line first. Okay, so again, red line is negative. It's going down left to right. The y-intercept. Let's go ahead and write the equation y equals mx plus b. So for the red line, our y-intercept is at +2. I think that's a good point. I start at the bottom. So if I do rise over run for my slope, I'm going to rise 1. Run, again, if I go to the left, that's a negative direction, so -1. And 1 over -1 simplifies down to -1. So now you're ready to plug in. Y equals -1 x. Our slope is positive this time, so +2. And the only thing I would change here is we don't need that 1 in front of x. And so it's just -x plus 2. Okay. This is a blue line. We'll call it blue. Looks like it's highlighted in blue. It has a -4 y-intercept. That's my b value. Again, I need a point. Rise over run again to get my slope. So rise 1. Notice this one is increasing left to right, so that's a positive sloping line. We should get a positive value. And when I go to the right, that's +1. 1 over 1 simplifies to 1. So this equation for this line is +1, and just like above, I don't need that +1 in front of x. My slope, or my y-intercept here is -4, so we're going to insert -4. So the system is -x plus 2 and x minus 4. Aloha spends his free time doing yard work over the course of the summer. The table shows the relationship between this time spent mowing and the income Lowell earned. What is the rate of change? We have talked about this a lot. rate of change is a synonym for slope. Okay, so I'm going to look again on my reference chart. My equation for slope of a line, y2 minus y1 over x2 minus x1. So I'm going to use the first 2 points. These vertical tables, this is my x, this is my y value. So this is x1, y1, x2, y2. And simple things like labeling these points makes inserting them into your equation a little bit easier. So y2 is 1,975. x2, there we go. x2 is 11. Minus on the top and minus on the bottom. y1 is 925. x1 is 5. All right, I want you to pause it, and you're going to put this in the alpha y equals of your calculator. Good thing about putting it in your alpha y equals, it will do the math and simplify it all in one step. So our rate of change is 175. This is going to be dollars per week. Evaluate the function f of x equals 4 minus 9x. So I'm going to write that so we can work it. 4 minus 9x for f of 3. Evaluate means we're going to figure out what is the solution when I plug in 93 for the place of x. So 4 minus 9, always substitute inside parentheses, -3. Again, I want you to pause the video, work it out, and then check to see if you get the same thing. All right, so when we evaluate the function for -3, we get positive 31. So make sure you type it in exactly the way that we have written, okay? Evaluate means plug it in. All right, write an inequality. It's not an equation for each of the following. So we should have 2 inequalities, not a system, just a couple of different problems. It says Liam is selling cookie boxes. To raise the money for a trip he's taking, he will sell each box of cookie for $7 and pies for $11.50. He would like to have a minimum profit of $85. So one of the things that I've talked about in class is to make sure that you are identifying what your x and your y is going to be. So for A, I'm going to let x be cookies, and I'm going to let y be pies. Okay, so one of the things that goes with that is that money. So cookies are selling for $7 and pies are selling for $11.50. Now it makes it much, much easier to write my inequality. So 7x, that's my cookies, plus all the pies that I sell, so $11.50 y, and I need a minimum profit of $85. Minimum means that's the smallest amount. I can have more, but that's the smallest amount that I'm raising. So this needs to be greater than or equal to 85. All right, B. Cowboy Hat Company will provide a free gift wrapping for orders over $120. Rope hats, which are going to be R, so this one tells us what variables to use, sell for $22. V is going to be visors, and those sell for $17. Write an inequality to represent how much one would need to order to receive free gift wrapping. Okay, so they need to spend over $120. So 22 times the number of rope hats plus $17 times the number of visors, and we need over 120. Can't be equal to because that's exactly 120. It says over 120, so it's a greater than. All right, let's look at number 6. The graph y equals 1/4 x plus 3 is shown on the grid. which of the following ordered pairs is in the solution y is greater than 1/4 x plus 3? So this equation is already in slope-intercept form. That's a good thing, because if it's not, that's the first thing that we need to do is get it in slope-intercept form. Even though they're giving us the line, you have to get your inequality or equation in slope-intercept. So when I look here, now I'm using this symbol to think about what kind of line and where would I shade. So if I were to change this graph to meet this inequality, this would now be a dashed line. So I'm going to change it to look like a dashed line. Greater than means everything above is the solution. So I've changed my line. I made sure my equation was in slope-intercept. I changed my line and I shaded. Now I'm going to start plotting these points and identifying, is it a solution? Okay, so 2, 0. So over 2, 0. That's not in the shaded region, not a solution. 0, 7. In the shaded region, that's a solution. -5, 5. In the shaded region, yep, that's a solution. 5, -5. So now we're going the opposite direction. Way down here, nope, not in my shaded region. 7, 0. So over 7, nope. 0, 5. Yes. Remember that if I am asked about a point that is on the line, it depends upon the line. So if it's dashed like this one, that would not be a solution. If it's a solid line, then it would be included. So not part of the question, but things we want to remember for our test. Write an equation in slope-intercept line for a line that passes through 6, 3, and 5, 8. Okay, so the first thing we want to do is go look at our reference chart and figure out what is slope-intercept form. Slope-intercept form is y equals mx plus b. So that means I need to know the slope and the y-intercept. So slope is easy. We can calculate that. So slope of a line is y2 minus y1 over x2 minus x1. Don't have to have that memorized. That's on our reference chart. So I'm going to label x and y. Those will be my ones just because it's listed first. It doesn't matter. X, then y. These are my 2's. I'm going to plug them in. So y2 is 8. x2 is 5. Remember, ordered pairs need to be on top of each other. Always subtraction. Plug in your other point. So the y is 3, the x is 6. And again, I'm going to put this in alpha y equals. So pause the video, put it in your alpha y equals. So the slope of this line is at -5. Okay. Now we need the y-intercept. Well, the y-intercept is where x is 0, so I don't have that from these 2 points. So when given a point and given the slope, we have to start with point slope form. Again, you don't have to have this memorized, you just have to know where to look. So point slope form, y minus y1 equals m times x minus x1. Again, I'm going to use the ones that I labeled up here in the problem just to plug in. So y minus, the y value is 3. We calculated the slope, that's at -5. X minus, and the x value is 6. Now, again, the problem says it needs to be in slope-intercept form, so I can't stop here. It's not there. So I need to solve for y. So I need to distribute the -5 to get rid of the parentheses. So we have y minus 3. -5 times x is -5x. -5 times -6 gives us +30. And last, I need to move this -3. The opposite of subtraction is addition. So I'm going to add 3 to both sides. And that's going to get us slope-intercept form. So y equals -5x. 30 plus 3 makes 33. Okay, so look what we did. We calculated slope. We plugged it into slope-intercept form. Then we solved for y to get it in slope-intercept. So this one is easier. It just says, what is the slope of a line that passes through the points -311 and -5, -2 in decimal form? So they're telling us this one's not going to work out nice and neat and pretty. All right, so I want you to pause it, and I want you to try to do this one. Label your points, plug it into slope-intercept. All right, so I'm going to pick up right here. So I've labeled my first points with x1, y1, my second points with x2, y2. I wrote my formula, and I've plugged in those first values. I've gone ahead and written my subtraction that's part of this formula, okay? Subtract. Now I'm going to plug in the second set of points, which is the ones. Y1 is 11. Y2 is -3. This is where I see a ton of mistakes. So make sure you write your subtraction, then substitute in your values. And again, we're going to put this in alpha y equals. So pause it, plug it in. So the slope here is 16. No decimal form to put in. If it were to have given us a fraction, so let's say, for instance, I work a problem out that's similar to this and we get 4/3, and the problem says, okay, you need a decimal, then you would just take 4, divide by 3, and that would give you the decimal form. Again, this one wasn't necessary, but know how to get a decimal if it gives you a fraction. All right, graph the solution set for the following inequality. We've got a system. We've got 2 inequalities. Okay, so our first one is x minus 2y is greater than or equal to 6. Okay, we talked about in a previous problem, these have to be in slope-intercept form. So the first thing I need to do is solve for y. All right, so if I need to solve for y, that means I need to move the x and the 2. So I'm going to move the x first, which you have to. It's positive, so we're going to subtract x from both sides. Careful here, this whole thing comes down, -2y. We have -x plus 6. 6 was positive up there. Now we need to divide by -2. We're going to divide each term by -2. And then we have our goofy inequality rule. If we divide both sides by a negative, which we just did, we have to flip the inequality. That's super important to watch for in all inequality problems. All right, we want to look right here. We have negative. Let me highlight so you know where I'm looking at. Negative x, come on, highlighter. There we go. Negative x over -2. Okay, so that number in front of x is like a -1. So if I were you, I'd put it in your calculator and simplify it, again, in alpha y equals. But a negative over a negative makes a positive. So this has a slope of positive 1/2. And then 6 divided by -2, again, you can put it alpha y equals, it will give you -3. So our slope for this line is 1/2. Our y-intercept is at -3. So now we're ready to graph this one. So plot your y-intercept. We have a positive sloping line of up 1/2. Okay, all right. Now let's go look at our inequality to decide what type of line we need to graph. Where'd my problem go? There it is. So this is an equal to, so that means it's going to be a solid line. So less than or equal is going to be solid, and we're going to shade in below the line. I've got a lot of points. I can make a nice straight line. Get my highlighter and shade in everything down here. Okay. Remember, with systems of inequalities, we were looking for a region of overlapping shaded area. All right, so I'm going to do the next one. Same process. I need to solve for y. So just like in the previous problem, we need to move x first. It's negative, so we're going to add 3x to both sides. We have 2y is greater than, not equal, 3x minus 10. Now we're dividing by 2. It's positive, so we're not flipping the inequality. Okay? Only when we divide by a negative. So 3/2 doesn't simplify. That's going to be our slope. Negative 10 over 2 does simplify. Again, put it in alpha y equals, let it do the math for you, negative 5. So y-intercept, negative 5, slope of 3/2, greater than is a dashed and above the line. So let's graph the line first. Positive 3/2, so we're going to rise 3, 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Opposite direction, 1, 2, 3, 1, 2. Okay. So now that I have my y-intercept, I have my line. It's going to be a dashed line. Do our best to get a dashed line going through those. And we're shading in, we said it's greater than, so we're shading in above. All right, so important, because you could see a problem that asks this, the solution are going to be points that fall anywhere in this overlapping shaded region. It can be on the solid line. It could not be on the dashed line. So anything that falls right here on this dashed line is not a solution. This solid line is a solution. Okay. Notice, we solved them both for y. We graphed them. We had to know how that inequality was. And then we shaded in to get our solution set. All right, graph the following equation. Lots of graphing here. Test is going to be very interactive. Like I said, you're taking it on the iPad or on paper, but all of these you're creating. All right, so not in slope-intercept form. We got to solve for y. Again, tired to read. All right, 2 times x is 2x. 2 times negative y is negative 2y. Now, like on the previous problems, we want to move that x. It's positive here, so I'm going to subtract 2x from both sides. Negative 2y comes down. And again, we're dividing each by negative 2. Not an inequality, so I don't have to worry about flipping anything. Negative 2 divided by negative 2 is 1. 1x, that's going to be our slope. Negative 12 divided by negative 2 is positive 6. That's our y-intercept. So pause it, graph your line. All right, so I started again, that y-intercept, rise over run, 1 over 1, so up 1 over 1, and created my line. All right, what is the solution to this equation? We are solving for x. Notice there's just x's. We've got to get rid of parentheses, combine some like terms, move some things around. All right, so let's get rid of parentheses first so we can make a plan. Again, we want to look at the number that's directly in front of the parentheses. That's what we're going to distribute. So negative 14x, we're not doing anything right here. So 6 times x, 6x, 6 times 7, 42. On the other side, we got another set of parentheses, another 6. So 6 times negative x. 6 times negative 10 is negative 60. All right, so I'm going to look at just the left side of my equation, and I'm going to combine like terms because I see I've got 2 x's. And so before I start to move anything, I want to get those combined. So negative 14 plus 6 gives us negative 8x. Everything else is coming down. Okay, now I want to move my letters left, numbers right. So I want to move the negative 6x. The opposite of negative is to add 6x. Those will make the 6x's cancel out. Negative 8x plus 6x gives us 2x. Negative 2x. Pay attention to my negatives there. Everything else is coming down. Okay, now I want to move numbers to the right, so I'm going to subtract 42. Got a big old number here. So negative 60 and negative 42 gives us negative 102. Divide both sides by negative 2. 51. Yep, positive 50. All right, this is a good one for us to talk about. What is the domain and range for the total cost to purchase pullets? I don't know what a pullet is. Doesn't matter. We just got to write the domain and range. Ooh, whoa. Undo what I did there. All right. Notice these are dots, and the dots are not connected, okay? When these are dots and they are not connected, it's not continuous. So I don't write domain and range as an interval. Here we're just going to list values. So domain is the x. And here, along the x-axis, we list them smallest to largest, left to right. So the very first x value is 1, and we've listed 1, 2, 3, 4, 5, 6, 7, and 8. Range is the same thing, but now we're going to go bottom to top because it's the y values. And this is an approximation. Looks like each of these is kind of halfway in between these points. And I'm going to read the y-axis, which are these values. So my first y value looks like it comes between 100 and 150. So that's going to be 125. Then 150. Oops. 175. 200, 225, 250, and so on. We got the 275 and 300. The point being here is that when it is not a line, if it were a line like this, we would write it completely different. But when it is a list of points, you are literally listing each value, smallest to largest, depending upon whether you're looking at the x or the y. Right. All right, that's all for today. Make sure you understand these, go back over them, make sure everything works. Tomorrow we'll look at another set of problems.